Alright, here we're asked to put an equation into slope-intercept form, which is basically solving for y. Right now this equation is in what's called standard form, which is the ax plus the by equals c. It's in standard form. To put it into slope-intercept form, we're looking to put it into the form of y equals mx plus b, where m represents the slope and b represents the y-intercept. That's the slope. So, in order to do this, you notice from this equation what we need to do is we need to isolate our y variable by itself on one side and everything else on the other side. So to go back to our original equation, what we're going to do, we take our 2x plus our 3y equals 6. Since we need to isolate the y, we're going to try to get rid of this variable, the 2x. And the way we get rid of the 2x on the left side is we simply need to subtract it out. So whatever we do to one side, we got to do it to the other side, subtract out the 2x. Well, these two cancel out, so I'm left with a 3y. Now, notice the 6 and the negative 2x, I cannot combine because they are unlike terms. So I want to put actually, believe it or not, I want to put the 2x right next to the other side of the equal sign and check back the 6. The 6 is a positive 6, so it would be the same as if I add 6. Now, it would be true to be okay to have the 2x after the 6, but understand slope-intercept form, I'm trying to get the x right on the other side of the equal sign to the y, so that's why I'm going to put the x in that place. And now, if you take a look at it, I'm close. I have the y's on the left side and everything else on the right side, but I still have this 3. I need to get rid of the 3. And it's saying 3 times y, so the way I get rid of that 3 is the equal but opposite operation of multiplying something by 3 is dividing it by 3. Now, whatever I do to one side, I got to do to everything on the other side. So obviously the 3's cancel out to 1, so I'm left with y equals a negative 2/3 x plus 6 over 3. And 6 over 3 can be simplified into negative 2/3 x plus 2. And now that I'm in slope-intercept form, I'm able to perform some operations or look at some interesting stuff. Since I'm down to a single y value, I can see that this number right here represents my m, or my slope, and this represents my y-intercept, according to the graph up here. So I have a slope of negative 2/3, and I have a y-intercept of 2. So I can actually graph this equation by simply first looking at the y-intercept. I know it crosses the y-axis at a value of 2, so I go to 0, and I go up 2 units, and that's where it crosses the y-intercept. And my slope here is negative 2/3. So if I start at my y-intercept, and I know my next point on the line is going to have a slope of negative 2/3. So remember, I have for my slope, it's rise over run. So my rise in this case, negative 2, is basically going down 2 units. So I go down 2 units, and then I need to run over or go over in the x direction 3 units. And that puts me right there. And I can continue this whole idea with slope down 2 and over 3, and I can make a series of dots, and they will all lie on the line, because remember, every point on the line has the same slope, and I can connect these dots, and I would have the graph of the equation of the original equation of 2x plus 3y. So that's how I can graph a formula that's in slope-intercept form.